This brings up aim 1. Does the pre-TFH require increased IL-6? And what makes the IL-6? And here we talked about IL-6 being produced by, well, the B cell for one thing. It also could be produced by stromal cells, or it could be produced by the macrophages or dendritic cells in the follicular area here. So that's over here. This is all aim 1, the generation, what comes first. And the experimental plan might be to block IL-6. Now I mentioned IL-6 receptor signaling is complicated because it's IL-6, signals to a receptor. IL-6 binds to a IL-6 soluble receptor, and then that binds to a thing. Okay, now the next thing I thought was very interesting, we got into tolerance. And here, talking about Mark Jenkins and another person who discovered what are the critical T cell tolerance molecules in the T cell. In other words, the T cell receptor signaling that's tolerant interacts with CD28, and there's a molecule that's produced that maintains that tolerance. So once the TFHs come out of the germinal center, well, actually out of the T cell zone, get pulled over. Here we go, right here. Gets pulled over. They start to upregulate IL-21 receptor. And start to upregulate IL-21. They start upregulating. Of course, they already upregulated CXCL13. They're migrated to FTCs or CXCR5 that migrates to CXCL13. And then I did wonder, why do the plasmablasts get in between? I didn't understand that. Why don't they just go, for example, on the other side? But as this occurs, the plasmablasts build up and separate the light zone here from the mass of T cells. We've seen that many times. But anyway, the TFHs are in here, and the next thing is now that they're ready to interact with the B cell. And what happens here? That's over here. They start to interact with the B cell. Now we know that one thing, there's several things that could be the problem here. One is they could come in already superactive. They could have been exposed to too much IL-6 or IL-21, so their activity is already high. They could actually come from a thymus that, we never studied tolerance loss from a BXD2 thymus. They could actually have tolerance loss, and then they come in already kind of activatable. We don't think that the T cell receptor is critical because we did the 2D2, BD2, which is MOG-specific T cell receptor, and it doesn't matter if that T cell receptors, if you give them MOG, any T cell, the T cell, once it's there, TFH say, just having that T cell there, it'll stimulate the B cell that's being already tickled with autoantigens, so it's B cell receptor. It will drive this. The key driving forces are probably IL-21, since we know that it has a devastating effect, or CD40 ligand. But that's the B cell drive. But which is first, the tolerance loss from the thymus? Now, one way to look at that is down here. You can take, to study tolerance loss, you can take the B6 and BD2 B cells, pulse them with MOG, and then co-culture them with T cells from the 2D2 BD2 mouse. And you could even sort these cells, the 2D2 BD2 into TFHs, TH17, TH0s, and then incubate those with the B cells, and then look at proliferation and cytokine. We did this once with tridatatymidine, and BD2B and BD2T really had high proliferation, but we didn't do it very well. So this would show whether they have tolerance loss, and are the B cells the critical ones, or are the T cells critical? And I was thinking using the EDU approach, so you could stain them intracellularly along with surface markers. For example, you might be able to stain for some of these surface markers like CD40 ligand, or intracellular IL-21 production, or CD28 expression, although that's all pretty hard to do, but to see what the mechanisms of tolerance loss are. It could be that this is the mechanism, that they're tolerant enough, they don't interact through cognate interaction, but by coming out, the TH17, IL-17 intensifies their interaction right here, and that just makes them interact in a longer period of time. So instead of bumping each other for a short amount of time, as you put up here, you put 0 to 12 hours, they do this, and finally they break tolerance. Maybe the number one thing might be through CD28, CD86. And I believe also they maintain T cell receptor tolerance. So we have to go back to this and see what that flip is, that molecule. T cell receptor tolerance is maintained. You could show it by this experiment, but the co-stimulatory signals, very strong, allow them to break tolerance in another way, just by over co-stimulation. IL-21 goes up, CD40 ligand goes up, and then you get to this situation. Once this occurs, you get overdrive by CD8086. You get overdrive here by these molecules, and then you get a very high level of B cells that can now make AID and autoantibodies. But one thing we talked about was the transfer experiment too, of BXD2 TFHs in the B cells. I guess that's right here. So you take the BXD2 CD45.2 mouse, which is what we have, and you buy a B6 CD45.1, take the T cells, TFH from the BXD2, transfer them to B6, and then you look at, you look at the B cells that in the B6, which would be CD45.1, and compare them to other ones. And then don't forget the other way. Take the B cells from B6 CD45.1 and transfer them to 45.2. And here, you take the B cells from 45.2 versus 45.1. In other words, B cells that are already in the BXD2 mouse versus B cells that are transferred in from the B6 mouse, and see if TFH can induce tolerance onto these B6 cells. And you look at that by, over here, you do the sorting on 45.1, 45.2, and then do a lysis spot. We talked a little bit about IL-6 being a key factor. That's it back up here again. Is IL-6 the main thing, and that upregulates what? CXCR5, downregulates CXCR7, or what does it do? So we talked a little bit about you can determine the response of IL-6. For example, we already know this, that IL-6 is high in BXD2 with age, but to look back at this data, how does IL-6 go up with age in B6 versus BXD2? And then there's also this experiment. You take the B cells out, T cells and macrophages, stimulate them with LPS, and so the IL-6 is not high in B6, but is very high in BXD2 mice. We also have this kind of data where we looked at all the strains of mice, BXD2, all the BXDs, different strains over here, and we gave them adenovars, AdVac-Z, and all the strains. We measured all the cytokines, and it'd be interesting to see where is BXD2. I predict it'd be out here. It would make very high levels of IL-6.